The universe is full of riddles that have never been solved. In today's video, we will explore why are some black holes called impossible? Where can you run into ghosts in outer space? And what objects and phenomena in the universe are the most enigmatic? Join us as we explain what James Webb Telescope detected on Jupiter this time. Welcome back to Futureland, your friendly and most reliable source of tech news, the latest gadgets, and anything related to the tech world. So if you're ready, let's get to the video. We humans have always been utterly intrigued by the universe. The universe contains estimated galaxies for over 1 trillion. Although a sizable portion of space is still unknown, advances in science and technology have made it possible for humans to see the limitless universe and be enthralled by its size and singularity. The renowned James Webb Space Telescope is yet another invention that has greatly expanded our perspectives. The CSA, ESA, and NASA worked together to build the JWST. It was sent into orbit in December 2021 and has since proven to be a great advancement in astronomy, technology, and space science. The JWST's main objectives are to discover the first galaxies that were created in the early universe and to observe stars that were forming planetary systems. Some of history's most fascinating discoveries have thus been made by the JWST. The telescope discovered an exoplanet, a nebula, and many more fascinating objects. These discoveries have given us a completely clearer aspect of the vast cosmos, by confirming some past views to be false and other less widely accepted hypotheses to be quite true. The JWST is altering the way we view the cosmos. For instance, there are a lot of rumors that have been floating online about the Big Bang Theory. The Big Bang Theory has been disproven, according to critics, though many renowned institutions and figures are of the opposite opinion. The JWST has also just taken images of Jupiter that have never been seen before, and scientists have for the first time seen something enormous occur in Jupiter. The largest planet in our solar system, Jupiter, is the 5th planet in its orbit around our Sun, with a mass slightly just under 1,000 times that of the Sun. Jupiter has a diameter of 139,820 kilometers and a surface area of 61.42 billion square kilometers. Jupiter's composition, which primarily consists of hydrogen and helium, is remarkably similar to that of the Sun. The hydrogen gas was compressed into a liquid at a higher pressure and temperature in the deeper atmosphere, creating Jupiter, the largest ocean in the solar system. It is currently the focus of global attention due to a major observation made by the JWST. On August 22, the telescope produced stunning photographs of the massive planet that allows us to see the planet's polar clouds as well as its northern and southern lights. 2 tiny moons and the planet's thin rings are shown in a spectacular wide-angle image against a dazzling background of galaxies. The infrared images were allegedly purposely tinted in a variety of colors to highlight the features, according to American French research team. One image shows the enormous storm identified as Jupiter's Great Red Spot, which sticks out among many other smaller storms and is so large that it can fit our planet Earth. The largest and most recognizable storm system in Jupiter's observable atmosphere is called the Great Spot. Its characteristic hue is reddish. Its form is somewhat oval, and its width is 16,350 kilometers. Jupiter spins and changes its longitude in relation to the clouds, although it has remained centered at a latitude of around 22 degrees south. Although far larger, the Great Red Spot resembles a storm on Earth. The giant red spot on Jupiter is more than twice as big as Earth. 270 miles per hour wind gusts are possible during this storm. Since American astronomer Carl Walter Pritchett first recognized the large red spot in 1878, it has been often observed. Deeper investigation and analysis have been done by the Galileo and Voyager missions. When observed through telescope from Earth, its color can range from light red to grayish. However, it might be challenging to distinguish it from the nearby cloud belts. Throughout the 19th century, the spot's width was roughly 48,000 kilometers, and it has been getting smaller ever since. The area has been shrinking and becoming more circular since 2012, and it is doing so at a faster rate of roughly 900 kilometers per year. A high-pressure center with an anticyclonic circulation system is what the meteorologists refer to as the Great Red Spot, which is located in the southern hemisphere. The entire system revolves counterclockwise for about 7 days, equating to a wind velocity of 400 km per hour near its edge. The red color has been attributed to a variety of unknown things, including organic debris, sulfur and phosphorus-containing chemicals, lightning discharges, and high-altitude photochemical reactions. The Great Red Spot is much above Jupiter's primary atmospheric layers. It is not connected to any particular trace on the planet's surface, which suggests that Jupiter is fluid everywhere. It is more likely to be the magnitude of an enormous cyclone, powered by the condensing of ammonia water or both at lower altitudes in Jupiter's atmosphere. However, a detailed explanation describing its energy supply and sustainability has not yet been found. Its immense size probably plays a role in its exceptional endurance. We have never seen Jupiter like this, according to the planetary astronomer Imke de Potter, who conducted the observation. The worldwide teamwork for Webb's early release scientific program allowed Potter and Thierry Fouché, a professor at the Paris Observatory, to do this jointly on the investigations. Potter stated that they haven't honestly foreseen and predicted such an amazing data. The fact that we can see fine points of Jupiter, its rings, minuscule moons, and even galaxies in a single shot is quite amazing. Judy Schmidt, a citizen scientist, worked with scientists to convert the Webb data into photos, saying that this type of detailed photograph of Jupiter was the first of its kind. The two photos were created by using the observatory's near-infrared lens. Since the naked eye cannot perceive infrared rays, it has been projected into an apparent wavelength. The shortest frequencies are often portrayed as being bluer, whereas the longest frequencies are generally displayed as redder. They seem white in these pictures because of the large red patch and surrounding clouds bouncing a significant amount of sunlight. The brightness implies that you are at a great height. So, the large red area such as the equatorial zone includes higher elevation hazes, explained by Heidi Hamel, the Vice President of Science at Aura and Webb Multidisciplinary Scientist for Solar System Investigation. The myriad dazzling white patches and streaks resemble the cloud tops of concentrated turbulent storms at very extreme altitudes. In contrast, the dark ribbons located north of the equatorial area are cloudless. From a wide field perspective, Webb examines Jupiter and its thin bands, which seem to be multiple times dimmer than the planetary, as well as two small moons identified as Amalthea and Adrastea. According to Fouché, the single image summarizes the concept of our Jupiter System project, which examines the behavior and composition of Jupiter, its own bands, as well as its own satellite network. Astronomers have already begun examining Webb's findings in order to gain fresh scientific knowledge about our solar system's largest planet. The data from observatories like Webb does not arrive on Earth in a neat bundle. After all, it contains information on the luminance observed by Webb's sensors. This information is received as a raw information by the Space Telescope Science Institute, Webb's Operational and Science Investigation Center. After processing, the information is validated by the STSCI and transferred to the Mikulski Archive for Space Telescopes for dissemination. While staff at STSCI technically processes Webb photographs for release, citizen scientists and amateur astronomers regularly browse through the public data library to acquire and process images. Scientists then interpret that data into photos like these during the phase of their studies. Judy Schmidt examined these fresh pictures of Jupiter. The image of the tiny satellites was made in collaboration with Ricardo Hueso, a co-investigator of these investigations who studies planetary atmospheres at the University of the Basque in Spain. Schmidt has no academic expertise in astronomy, but an ESA contest helped her uncover her intense desire for image processing 10 years ago. As part of Hubble's Hidden Treasures competition, the general public was urged to browse through the Hubble data in search of undiscovered discoveries. And with that, today's video comes to an end. Don't forget to hit the like button, subscribe, and turn on the notification bell to be always notified whenever we have a new upload. Thank you for watching Futureland, and we'll see you in our next video.